students, welcome back to our geography class. This is lesson 2 where we're going to talk about our universe. But before we get started, pause the video and just let me know how you guys are doing. Sometimes it helps to just vent about whatever, and unfortunately not everybody has family or friends that are open to hearing them, so feel free to do that here. If you want any advice or just want to share something great that happened in your life too, feel free to post that in the comments section below. Otherwise, to get started, we're talking about the universe, the solar system, and all that happy stuff. This is not an astronomy class. This is not a cosmology class. We're going over this just to get sort of a basic overview. Most of this is going to be a review for a lot of you. This is part of, I think it's still in the first chapter of the book that we're using, which again is targeted towards teenagers, typically middle teenagers, so between ages about 14 and 17. So our universe is pretty old, 13.772 billion years old. Some people just round up to 14 because for us non-astronomers, we're not doing calculations with it. Doesn't really matter. So if it's easier for you to remember 14 than it is 13.772, feel free to go ahead and just kind of do that. About 14 years old. How do we know that? This is based on our ability to date different particles and clusters in a variety of different ways. And if you want to learn more about that, I've posted a couple links in the details section below. The links themselves, they're pretty short. You may need to reread it a couple times just to get an idea. But basically, it's pretty straightforward. And once you understand some of the technology that we use, you'll see it's pretty easy to date the universe. Easy in terms of it's pretty straightforward. Not that it's an easy, like, quick process like arithmetic or something like that. And it's definitely not a guess. And that's just really what I want you guys to remember. But speaking of guesses, how did the universe start? We actually don't even know. Some people claim to know. Always be careful of people that claim to know something that they cannot demonstrate. So there are some different scientific ideas that we currently cannot test. So that's why they're ideas. They're not hypotheses at this time. They're not theories either. A theory, remember, from your science classes, a scientific theory is something that we've studied, we've observed, we can use it to make predictions, and we basically say, yeah, this is, as far as we can understand, how this thing happens. So we're not talking about theory in like a general English use where it seems to be like an educated guess. So what are some of the ideas? One of the ideas could be that we are in a multiverse, which some people refer to as the cosmos, and we're just a little piece in that cosmos. You can kind of think about it like the cosmos itself is made of, matter and energy, and just as those things naturally interact with each other, sometimes they will produce a universe in the same way that a seed will interact with its surroundings and produce a plant. So that's a way that you can think about it. Another idea is that we're in a simulation, that this is some kind of computer game or some program that somebody had created, and we're in that game. So there's some pretty interesting ideas there. Other stuff that isn't really part of the scientific community, but definitely has been part of the human society for quite some time, is this idea of a creator deity. So there could be a god or goddess or multiple deities that have set the universe in motion. If you guys want to post any other ideas that you have, or which one you think seems more likely, feel free to post that in the comments section below. For me, I don't know which one seems more likely. I hope we can get closer to it in my lifetime, but I don't think that's going to happen. But it might. One thing that I do want to say is that there is a mischaracterization of an idea, this idea that everything came from nothing or the universe came from nothing. So this is actually an argument issue called a straw man, where if you're having a discussion with someone, you misrepresent their statement to make it something that's more ridiculous and easy for you to pick apart, rather than actually addressing what they really said. No person believes that everything came from nothing. Nobody thinks it's likely that everything came from nothing. Typically, for the people that fall more on the deity creation kind of side of it, those people may misrepresent the non-deity creation side of it as, oh, well, you think everything came from nothing. So I just want to make sure that we know that's not a statement that people actually take seriously. But after it started, however it started, we do know it expanded. And we can see it's actually still expanding, which is pretty interesting. We thought that it would slow down, but it seems to be speeding up. And this gives us some more ideas about maybe there's things that we can't detect, repelling stuff. Could it be dark energy, dark matter? So this kind of goes down a totally different, this is not astronomy class kind of discussion. The CMB that you're seeing on the screen, it kind of looks like the globe. It's not. This is a representative of what we can observe in the universe, and this is the cosmic microwave background. Part of the CMB is helpful for us to date the universe, which is pretty cool. So this expansion here is called the Big Bang. I really hate this phrase. I like to just call it the expansion of the universe, because when you think of bang, you tend to think of an explosion, disorder, destruction, those kinds of words, and that's really not what it was. It was just a point that had expanded. That's all it really was. So the CMB really helps us kind of understand this, the cosmic microwave background. This is a temperature map. Now, I know it looks like there's some parts that are exceptionally hot and other parts that are quite cold, but actually the difference between this is only a small difference. It just over, they had made it seem so distinct just so it's easier to tell apart. The cool thing is that we had actually predicted the cosmic microwave background, and then we said, all right, if it's something that we can detect, this is how it should look, and we made a model of it, and then we found it was almost exactly that model. So it's really cool predictive power. That's one of the awesome things about science and math. I know it, for some of you, science and math are maybe not your thing, but do know that it is doing some cool stuff behind the scenes for sure. On the other end of it, it appears that the universe is going to end in something called a heat death. Please don't think about it as death by heat, but think about it as the death of heat. So that as things continue to expand, eventually these particles are going to stop interacting with each other and things are just going to go very, very cold. So things will die in that way. If you could be there, would you want to? Just to see what it's like? I don't know. I think it'd be interesting. Assuming that my body stays together, my mind stays coherent, and I can just kind of hang out and float around in space and observe this, I don't know. I feel like it'd be an interesting thing, but then, you know, what next, right? And that's the kind of the exciting idea that I get from heat death is what next? Does anything happen next? Is it like a body that decays and then the pieces get reused in some other way? So I don't know what happens after heat death. But it's kind of fun to think about. In the meantime, between the Big Bang and heat death, we get a bunch of star recycling. So basically, we start off with a couple simple elements, which are namely hydrogen and helium. Once they come together in a gas, they kind of start to collapse in on itself because of the gravity. And then when the star begins to kind of heat up, it really turns into like a nuclear fusion, atom smashing machine, to use the quote from They Might Be Giants. Maybe I could put a link to that. It's kind of a fun song about the sun. From there, we get other elements. So this is a basic overview. Again, this is not an astronomy class, but just so you guys can kind of visualize how this works. We start with a cloud of gases. Eventually, they begin to stick together or come together and build up enough gravity where they kind of collapse into a star or an early star. And then we have all this extra stuff around them, which eventually becomes planets. Then, as you guys likely know, the star will explode, such as like a supernova. We can end up with neutron stars, black dwarfs, white dwarfs, black holes, white dwarfs. There's a brown dwarf, and a lot of those other gases become a nebula. So we end up remaking that star nursery, sometimes nebulas are called. So again, this is just kind of a way to look at it. As you guys probably remember from your chemistry class, if you have an atom, or sorry, you have an element where there is the same amount of protons but different amount of neutrons, those are called isotopes. So these are different isotopes of hydrogen, here deuterium and tritium, and coming together we get helium and our free neutron. I guess it's just a bonus, right? So as we continue to do that, we're able to make other elements. We're able to make lithium, we're able to make stuff like gold, and then of course through this life cycle we can create new stars, we can create planets. Okay, cool stuff. Pause it if you have any questions. Otherwise, we're going to continue. Outside of our solar system, we have been able to spot planets. We've been able to look at other types of systems with stars and planets. It's a pretty interesting way that they figured out how to observe this. It's basically you observe a star, and then as you're observing the star through the year or 2 years and so on, you'll notice that the star's light will dim a little bit. And so it means that something has come between to block that light, come between you and that star to block some of that light. Pretty interesting stuff. If you guys know more about chemistry, you know that from afar we can actually observe sort of a signature of chemicals. And so we were able to do that and kind of figure out some of the basic chemistry of some of the planets, even outside of our solar system, which is super cool. That's totally awesome. That's something that has been discovered in my lifetime. So it makes me wonder what else can be discovered in your guys' lifetime. So the planets outside of our solar system, just to differentiate between inside and outside, those are called exoplanets. What we see here, and I'll put a link to the video in the details section below, we see different similar, like Earth-like planets, which is pretty fun, I think. Makes me wonder, you know, what could be there. Just to let you guys know, the most observed planet appears to be a large, like a gas giant that's really close to the star, and so we've nicknamed them hot Jupiters, and so that's their kind of nickname. So our solar system is just a quick like 2-slide thing. This is our location, so there's like a cluster of different galaxies, and that's our supercluster, our local supercluster, and then eventually we're just kind of off in one of the arms of the Milky Way galaxy, which is pretty cool. And then of course we're hanging out on Earth. This kind of gives an idea of how this was all formed, and again, I'll put a link to that in the details section below. So the book does want you to be aware of some planetary vocabulary, so we're just going to kind of run through that. For most of you, this will be a review or a reminder to kind of help you differentiate. The rotation is going to happen on an axis. Once it makes one full rotation, we get a day. That's basically that. A revolution is one object moving around another object, and the orbit is the path that it takes. So if you think about it like you're running around a track, for example, then you running around the track one time is you doing one revolution. The track is the orbit. Okay, so hopefully that'll help you guys remember it. So this is the movement of the thing. This is the path the thing takes, okay? And one complete revolution is going to be a year. So again, just to go over day and year, we measure this for other planets in terms of Earth hours or Earth days, just because we're Earth-centric, because we're Earthlings. Same idea with the Earth, or with a year. If we're measuring the year length of other planets, we do that in Earth days or Earth years. So our rocky planets are going to be the planets closer to the sun. I like this image. Pluto, of course, is no longer considered part of our planetary family, but I know some of you still consider it in your hearts, so I left it in there for you. The Mercury is going to be named for the Roman messenger god, and I know a lot of you guys have probably learned and remembered some of this stuff from your younger school years. So hopefully this will be just kind of a bit of a review, and then I gave some extra information just so it's not pure review. This image I really like because it really shows the scale of Mercury. I mean, this is our cool sun, I guess our hot sun hanging out, and then this little bloop here, That's Mercury. I mean, Mercury is one bad boy being right next to the sun. This is the approximate size of Mercury compared to Earth. So that's not our moon, that is Mercury. Pretty interesting, I think. So the symbol, these are these alchemical symbols. And if you guys want to know more about planets and alchemy, then I guess I can put a link to that in the details section too. I've included some pictures of Sailor Moon because that's probably where most of you have seen these images before. So the Mercury day is quite long. It's about 59 Earth hours long. Pretty long. But the year is only 88 days long. I'm sorry, 59 Earth days, and the year is going to be 88 days. So it does rotate a bit slowly compared to us. Just a bit, right? Now, Mercury's got some interesting action that happens. When we have an atmosphere that's basically gases that are stuck around a planet because of gravity. But Mercury being so close to the sun, either those gases end up becoming too hot to be stable, or the gases are blown away by something called solar winds. So it doesn't really have an atmosphere, and as a result, it can't really maintain a consistent temperature. So we have two parts of Mercury. There's a part, of course, that faces the sun, and there's a part that faces away from the sun. But without that atmosphere, those parts are going to be radically different in terms of their temperature. So the sunlight facing side is like 430 degrees Celsius, where the non-sunlight side is like minus 180. There's really no good place to be on Mercury. I'm kind of reminded of that movie, The Chronicles of Riddick, when they were on that planet Crematoria, and just how the sun coming up was super destructive. And that's kind of the idea you can think of there if you guys are familiar with that movie. No moons. Sorry. Sorry, Mercury. It's a lot less dense than Earth, so of course your weight is going to be less. Remember, your weight is the relationship between you and the gravitational pull of Earth. Your bonus fact for this is there is the most craters of any planet in the solar system. Our good friend here, why do you think that is? You can pause it, give you guys a minute, think about it. So two of the reasons would be no more plate tectonics. Whether Mercury actually had plate tectonics, we're not 100% on that, but they definitely had stopped if they did have plate tectonics. But it doesn't seem that Mercury did unless it was larger. Anyway, that's a different discussion. The other reason is it's so close to the sun. The massive gravitational pull of the sun is going to bring in a lot of these different debris that's floating around in our solar system. And so that's going to just hit Mercury just because. Like, think about it as you've got your cat or small dog kind of sitting on your lap or like sitting against your chest, and you're eating a really messy hamburger. Because you're doing that and it's so close to you, that pet of yours is going to get hit with any of these dripping sauces or crumbs. So that's a little bit of an analogy of why there's so many of those craters there. Now, Venus is named for the Roman goddess of love, as you guys probably know. It's pretty close in size to Earth. And for quite a while, people actually had thought there was life on Venus. This was before we knew exactly how hot it was. And again, with the Sailor Moon kind of, well, Sailor Venus imagery here. The length of the day is quite long compared to a year. So think about that. If we're looking at the length of the day, which is 116 Earth days, and the year is 225 Earth days, that's what, like a day and a half per year. What a funky looking calendar, right? The average temperature is very hot. It's actually the hottest planet in our solar system. Even though Mercury is right next to the sun, because Venus has a very thick atmosphere, it's able to retain heat even better than Mercury. So pretty cool. And again, no moons for our good friend. So because of the mass similarity between Venus and Earth, you are pretty close in weight. Your bonus fact here is that Russia actually had sent probes to Venus. There were several probes that were sent. This was during like the space race time period, and this was part of the Venera program. These are actual images from the surface of Venus. It depended on where it landed, the conditions that it was landing in, and what the lander was made out of, but it only could last for between 10 and 120 minutes. The surface of Venus is really not good for anything. I was going to say good for life, but obviously our machine friend here is not life. The atmosphere, like the air that you breathe, it's really corrosive. I believe it's sulfuric acid. It's really hot. It's really dense. Just not a good time. So you would either suffocate or burn up or be burned away from the acidic air. You know, which one will kill you first if you landed on Venus? So it's kind of an interesting. There's a million ways to die on Venus. It's like the Australia of the solar system. This is another image of Venus that has been colorized, really cool looking. You can see here it looks kind of like a volcano, and that's because it is. Venus does have volcanic activity. Earth is going to be our heavily populated one, right? As far as we can tell, we are, of course, checking other places in the solar system, but as far as we can tell, we're the ones that have life. This is a really cool shot of almost everybody that ever it lived on Earth, except for the person taking the photo, right? So we don't have a Sailor Scout for this one because she's Sailor Moon, not Sailor Earth. And of course, hopefully you know the length of the day and the length of the year, which is really what, 365.2 or 25. That's why we have that leap year once every 4 years. Now, the average temperature on Earth is actually 14.9 degrees Celsius, okay? But our highest and lowest, of course, hopefully you guys don't have to deal with that, but 56.7, it was in California. I believe it was in Death Valley, and the lowest is going to be about 89, minus 89 degrees Celsius. Not a good time. Stay inside, right? We got one moon. It's pretty nice looking. It's a cool looking moon. Okay. And our iron core is going to make that magnetic field that shields us from those electromagnetic waves. So the type of solar winds I was talking about that helps strip away any attempt at an atmosphere from Mercury, we're not going to have that problem. I think it looks kind of like an octopus. I like it. Or like one of those machines that was trying to get the what was it called? Those little octopus type machines in the Matrix, the first Matrix, and they're like trying to get the people that had left from the Matrix. I don't know. That's just kind of how I visualize it. We don't really use Roman names for Earth or the moon, so everybody's got their own name for it. Now, if we want to do it, we tend to do it in sci-fi if we're trying to refer to Earth, but we're trying to refer to it for some reason we're using like Latin names or Greek names. Then Earth is Terra. Terra just means like dirt. And then Luna is going to be the name of our moon. But however, we do sometimes refer to it in Greek, which is Gaia and Selene. And if you are a person who makes a map of the moon, that is a selenographer as opposed to a cartographer. So kind of interesting. Mars is going to be the Roman god of war, as many of you probably know. Yes, this is an ice cap hanging out here. Pretty cool stuff. Again, the approximate size, which is pretty interesting because they talk about, oh, maybe humans can populate Mars or we can move some people to Mars as a colony. It almost makes you think that they're pretty similar in size, and they really just are not. We got our good friend Sailor Mars here. The length of the day is pretty similar. The length of the year is also pretty similar. So I guess if we were to move to any planet, this would be the easiest to manage with our calculators. The poles of Mars are going to be pretty cold. They're minus 125 degrees Celsius. A summer day, because Mars does have seasons, the average summer day is about 20 degrees Celsius. Mars doesn't have a really thick atmosphere, but there is a little bit of an atmosphere. There are two moons that are very lumpy. They look like potatoes, I think. Potato Moon and Potato Moon 2. Okay, good times. Just again to show that size difference, we're about 38% of our weight. Now, one of the interesting things about Mars was before we had figured out that the sun is in the center of our solar system, the reason that Mars got associated with war, besides that it's red, which kind of looks like blood, is it looks like it's at war with its orbit. So if you do watch an orbit of Mars, it appears from Earth to actually go back and forth. It looks like a wanderer, that it's fighting with itself. And so this is where we actually kind of pull that name. It's kind of interesting. But because of this funky pattern, this actually helped us when we figured out, okay, maybe the sun is in the middle and we all orbit around the sun, and then Mars's orbit suddenly made sense when we did it that way. So pretty cool. Another bonus fact about Mars is that the tallest peak in the solar system is an extinct volcano, and it's quite large. Its slope is so gentle that if you were on the side of Olympus Mons, you probably would not know it. And again, it is an extinct volcano. Pretty cool stuff. This kind of just shows the difference between here we have Mount Everest and then we have Olympus Mons. So interesting stuff. Gas giants. Just me and the boys chilling in the back of the solar system. You're welcome. Made that for y'all. Jupiter is going to be our buddy here. King of the Roman gods. The biggest baddie that we got. How big is it? The diameter is like 11 Earths. Okay. So we're not kidding when we're talking about a gas giant. The day is actually pretty short. It has a really short rotation, or really quick rotation, I should say. But the length of the year really goes out. And we're going to get a lot of these these long years for the gas giants just because they're so much further away from the sun. I was always a fan of Sailor Jupiter. I don't know. Have fun with that. The average temperature, it's quite cold, but we think the core might be a lot hotter. But I guess that makes sense because Earth's core is a lot hotter as well. But that is our estimate, that it might be up to 24,000 degrees Celsius. Jupiter is very, very hungry for the moons. There's some different estimates on how many moons it has, depending on when the information was published, because we're always finding more stuff. So the last that I found is 79. So that's a ton of moons. If you could stand on Jupiter, would weigh about 240% of your weight now. So if you weigh 100 pounds and you're going to weigh 240 pounds, it's pretty interesting. Now, I like Europa, having a good time with that because it appears that there's water ice at the surface, and we don't know if there's more to it under there. So pretty cool stuff. Again, there's going to be a link to the video. Now, NASA did confirm it's going to send a probe to Europa. We're going to see if it has life. I'm very excited about this. The idea of the probe was confirmed in 2019, but so far it has not been built. I did go and check that again recently, and it's still just an idea, a confirmed plan, but otherwise it has not been built. Definitely hasn't been launched. But I'm so excited for when that happens. I just think what could be down there, you know, what kind of life could be there. And I'm always thinking like an octopus. I really like the cephalopods. So our big spot here, it's like a big old hurricane, and it's at least 300 years old, because when we first started observing Jupiter, the people that first started observing it noticed there's this big circle, there's a big red spot. It could be much older than that, or it could have only started recently, compared to when they had checked it out. But we know it's at least 300 years old. Saturn is going to be named for the king of the Titans. So there's different gods in the Roman pantheon. So there's like the Titans. Yeah, good times. So compared to Earth, our little blue dot here, Saturn is quite large. Of course, this is Saturn without its rings. It's got this funky looking H symbol, okay? And we've got a 29 Earth year Saturn year. So I guess most of you watching this, if you are students, you're not even a year old compared to Saturn. The average temperature is quite cold as well. It's got a bunch of moons. I'm a big fan of them. You can see some of them are very spherical, and some of them we got that potato look to them. So it's like a buffet of different moons here. Now, interestingly, Saturn is not that dense. So your weight on Saturn, if you could stand on Saturn, your weight is actually quite similar as to Earth. Now, I think this is really cool. It's one of my favorite features of any planets is going to be the hexagonal storm. So there's like a giant, again, like a hurricane, but it's in the shape of a hexagon, which is really cool. It has to do with the magnetic poles. But it's really cool that it just developed that way and it just spins around in a hexagon. I mean, how cool is that? That's great. Imagine like you got a hexagon coming after you. That's a bad time. Uranus is how we pronounce this. Uranus. And so this is the Roman sky god. And we can kind of see that with the color. This is sort of a sky color. When we look at Neptune, it's more of a deep blue color, and that's why Neptune is the god of the sea, and Uranus is going to be the god of the sky. It's going to be based on those colors for sure. There's actually two symbols for Uranus. I chose this one because this is what's used in Sailor Moon, but there's another one that's sort of a mix between two previous planetary symbols. It looks like a circle with an arrow and then a spot in the middle of the circle. So this is the coldest planet in the solar system. Even though Neptune is further away from the sun, this is going to be even colder. 27 moons. Got a lot of different moons of Uranus. These are some of my favorite moons. Not 100% sure why. I just kind of gravitate to these moons. I really like them. I have some designs of the different moons here, so I'm just a big fan. Again, this is not a very dense planet, so you're actually weighing less. Even though it's much larger than Earth, it's so much less dense that you weigh 89% of your Earth weight. And it actually has rings. I know we think of Saturn as a ringed planet, but Uranus also has rings. And you can see they're kind of tilty, right? Saturn, it's perhaps has tilted. We're not sure why necessarily that is, but cool. Its axis is a little bit different. So we can compare the color now, right? This is Uranus, that really lighter blue, that sky blue color, and then this is Neptune. So this is, of course, the sea god. This one is a little bit smaller. It is more comparable to Earth compared to the rest of the gas giants. And we've got that cool, like, trident kind of look here for that symbol, which is nice. 165 Earth years, so more than any of our lifetimes. That is the length of 1 year on this planet. Pretty interesting. But notice that the length of the day is a lot shorter than Earth's. So this is a planet that is rotating quite quickly, okay? It also does appear to have a very hot core compared to its surface temperature. And there's a bunch of moons here, which I always thought were kind of fun because they got like an oblong kind of shape. I don't know, maybe it's like whipping them around so fast, they're like pew pew, they're like stretching out. That's not how it works, but that's kind of how I remember it. Again, not a very dense planet. It does have the strongest winds in the solar system, though, and that's why I wanted you guys to focus on that speed that it's rotating. So we end up with these really strong winds. Pretty interesting stuff. We do think of Jupiter as the one that's all stormy and windy and cloudy, but it's also true with Neptune. It also has rings, and it's got a spot. So if you want all the bonuses of pretty much every gas giants, except for that super rad hexagonal storm, then you should be a big fan of Neptune. We got a spot like Jupiter. We've got winds and stuff like Jupiter. We've got rings. It's really cold. So we got most of those just packed together. Pretty interesting stuff. Speaking of stuff, what about the other stuff? Pluto. I'm really glad we've got this picture of Pluto. We didn't have this back when I was in school. It's really gorgeous. We did lose Pluto's planetary status in 2006. So it was a planet for a while, but not even 100 years. So it's basically Pluto being alone and sad. No, Pluto's not alone and sad. It's got other buddies, okay? So there's other things called dwarf planets that are in our solar system. So Pluto has joined their ranks. So it's still a planet, it's just considered a dwarf planet. Okay. There's also some other stuff hanging out in this thing called the Kuiper Belt. These are different types of the dwarf planets will be there. A lot of asteroids just kind of float around there. Interesting and fun time with the Kuiper Belt. But that is the end of our lesson today. If you guys have any questions, please feel free to post it in the comments section. I'll do my best to help you out with that. And if I can't help you out with that, I will at least link you somewhere that should be able to help you with it. Otherwise, I'll see you guys in the next lesson and have a good day. Bye-bye.